In this tutorial, we're going to talk about domain and range. And this should not be the first time that you have heard these words, but just to refresh your memory, a domain is the set of input values. Or in other words, the X values. A range is the set of output values. Or Y's. Now, we're not going to be really looking at the very basic kind of domain and range like what we've been used to. This time around, we're going to try to determine what an appropriate domain and range should be for different kinds of functions. And I'm going to try to show you a couple on here. It's going to be a little bit difficult, but just to get your mind rolling about what an appropriate domain and range can be. So here's an example. This function is called y equals 1 over x, and this is the picture of that function. Now notice that the y-axis is an asymptote for both of those branches, because in my function y equals 1 over x, what would happen if I plugged in 0 right here? Well, nothing would happen because we can't divide by 0. So it makes this line an asymptote. In other words, these branches here are going to get very, very, very close to that line, but no matter how far they go, we'll never touch it. That's an asymptote. So let's try to write out the domain of this function, and while we're doing this, we're going to practice using what's called interval notation. And that's probably going to be the most new part of this section that you're going to see. So to do domain, try to think of all of the x values that you have and always start from left to right. And it might kind of help if you trace over your function or kind of envision that these are roads and that you're driving a car on them. Sometimes it helps, sometimes it doesn't. We can go over that in class too. But if I start all the way from the left-hand side, that means I start all the way here, right? Now that arrow means that I go on forever and ever and ever to the left-hand side. So that actually means that this function goes all the way to negative infinity. But since infinity can never be reached, we're going to use certain notation for that. So I'm just going to get this set up here. I'm going to write negative infinity, and then I'm going to write a comma, and I'm going to write what it goes to. So if I trace along this line, I still have negative x values, more negative x values, and on the x-axis, these guys here, they're going to get closer and closer and closer and closer to 0, but never touch it. So this is going to approach 0 but never touch it. Because remember, I have to make sure that I'm including 0.1, 0.01, 0.001, the smallest decimal that you can possibly think of. I have to take that in consideration. Now, I'm going to back up just a little bit. I'm not sure if you remember doing inequalities, but if we have a less than sign or a greater than sign versus greater than or equal to, when we graphed these, this was an open circle and this was a closed circle. And the difference was that greater than meant that it represented any number greater than the number, just didn't include it. Whereas greater than or equal to, it can include that number. Well, when we do interval notation, we have something similar for that too. If we get really, really close to a number but never touch it, we're going to use an open parenthesis. If we include the number, we use a bracket, like that. So let's go back to our domain here. Now, I know that this particular branch went all the way from negative infinity, but I can't touch it. So that is going to get an open parenthesis on it. What about 0? Can I touch 0? Can I include it in my answer? The answer is no, so I need an open interval, or an open parentheses. Now, that only takes care of one of these branches. I have to include the other branches, and what we use is union, so that's going to be just a capital U without the hook, just like that. So we're going to take this piece and, that's what that union means, and all the values of x for this other branch. So once again, we're going from left to right. Now up here, this started at very, very tiny positive numbers down here on the x-axis. So that means all the numbers really, really close to 0 but not touching. So I'm going to do 0 again like this with an open parenthesis. Alright, let's start tracing. So this is going to keep going and going and going on and on and on forever and ever and ever, all the way up to positive infinity. Once again, we can't ever touch that, so we're going to use an open parenthesis again. So that's our domain. Let's take a look at our range. So range, it actually makes it easier to start from negative to positive, just like with the x's, so from bottom to top. So it looks like the very bottommost point here, this arrow means I'm at negative infinity. Well, alright, so I'm going to start with that. Open parentheses because we're not going to touch it. Now, how far up before I break can I go? So I'm going to go up and up and up and up and up, just like this, until I get to 0 again, because that's another problem. So I'm going to go all the way up to 0, but I can't include it. Now I have to take care of the other branch, so union. Now, we're going to start back at the very closest value to 0 again, and we're going to keep going up, just like this, all the way up to positive infinity. So, we have to make sure that if a value isn't there, that we don't include it in our domain and range, and that we start practicing interval notation. And it's pretty easy to get the grasp of. Let's take a look at one more function. Alright, so here's our next picture, domain and range. So, for domain, those are our x values, and we start from the left and move our way to the right. So the farthest left value that I have is this -3, right here. Now, can I include -3 in my answer, in my domain? And the answer is yes, because it has a closed circle on it. So that means I can put a bracket on this -3. Now, how far to the right is this function going to go? So I'm going to trace this function. I'm going to keep going, keep going, all the way to the right, and it stops at which value? And it looks like it's at 2. Now, can I include this value in my domain? The answer is yes, because it had a closed circle, so this also gets a bracket. All right, now what about range? So range, we start at the very bottom and work our way to the top, or the smallest value to the largest value. Now, the smallest value it looks like I have is this guy right here, which is also at -3. It's not this guy right here. Even though that's where we start, that's not the smallest value that we have. So it goes from -3, and I can include it because it's part of my line. And that's going to go all the way up to, let's see, what's our highest point here? It looks like it's right up here at +3. And we can include that again because it's part of my line. So this example is far easier to do for domain and range, but a different example. And that concludes this tutorial.